the way.
Okay, so let's do it.
Yeah, I'm fine.
Let's do
Can you
it
hear
in.
me?
Yes, yes, yes. So let's do it in the official way. So let me say welcome and shalom to everybody. Very, very happy to open today this fourth session of our series of online conferences on forestry in arid and semi-arid regions. And we are all from Mashaf side and from KKL side, very, very happy to be able to share our experience with you all. So today I have the honor to introduce Dr. Michael Sprintsin, who will share with us his presentation on GIS and advanced monitoring systems in Israeli forests. So let me say some words about Dr. Sprintsin. He's a forest engineer at KKL and he's appointed in the southern region of Israel. By training, he's a geographer with a background in forest ecophysiology and management, specifically focusing on dryland environments. And his expertise is in the implementation of geospatial technology in environmental science and applications. And I will pass the mic to him, and maybe he will tell us a bit more about himself and going into the subject directly. So Michael, the mic is yours.
Thank you very much. Good evening, morning, afternoon to everybody. We're from different parts of the world. Actually, I will share my presentation first. Let me know that you see it.
Yeah, everything
Okay,
fine. Yeah.
is okay.
Perfect.
Everything's fine. Okay. No, I don't have any other thing to add to this introduction. Thank you very much, Evelyn. And I understand this is the second last meeting that is on our list, and I really sorry that I missed previous three. Thought we have an hour and a half. I think it will be too long for lecturing, and I'll try to be as focused and as short as possible to leave some space for questions if they will be. And this is also because I really prefer the discussion rather than the lecturing. So despite what Shani told me, I think that it would be good. I don't have any problem with you stopping me in the middle, making comments, asking questions, remarks, whatever you want, because the discussion is always more productive, in my opinion, than this formal lecturing. Okay, so even if I will not be able to get to the last slide of this presentation, maybe we could find some interesting points to discuss, and this is and share the knowledge, which is always more valuable in my opinion. So we'll talk about advanced monitoring systems or monitoring systems in general in Israeli forests, how we use it, and what we do with this information. We will mainly talk about remote sensing, of course, but this is the main tool that we use in monitoring. And of course, the GIS that collects the data that comes from this source and wrap it up for decision making. We here in Kakal, we started discussing this topic a while ago, and have made quite a lot of progress during the last, let's say, more than a decade, by introducing techniques and directions to be further developed. And even more during the last several years, why the awareness and the advantage of remote sensing is quite clear to everyone. And even more, I would say that during the last decade or so, the massive introduction of cloud-based technology and ArcGIS Online specifically make it much more easier convincing foresters and managers that this is actually the future. Because I must say, and I still feel it in the air, that for many, remote sensing and GIS remain like a science fiction. Not everyone really accepts it as it is, and it is still something from above that observes us, and we have to use it somehow, and not everyone is understand it. So our duty is actually to turn it into practice. And it doesn't matter which size of the country do we have. Israel is a small one, and we can actually walk around and observe things and measure things, going in visiting every forest or almost every stand in a forest, and I did it several times already. But I think that we still have to be more technologically oriented. So I'll try to sketch the map of how we use the data that obtained remotely and how we convert it into the introduction. Maybe the last point for this first slide, I would say that I'm not sure if it was mentioned before, but we not a scientific organization, and we unfortunately, don't have any scientific or research unit per se, like many other forest services all around the world. But our approach is more practical. But what we do, we support the scientific community and researchers that could be beneficial to forest management. So I will talk about things that we do in-house and things that was done by the universities for us or in collaboration with research groups. Okay, so remote sensing, we all know what it is about, gathering information about physical world. The information that is gathered is from reflected or emitted radiation from the object that is located far away at some distance. And I think that the most important point here is that it is not only obtaining and processing satellite data, like many things. Of course, satellites play an important role here, but there is an entire spectrum of the platforms that are in use, starting with the aerial photography, very obvious and classical use of remote sensing, very old one. Simple stills cameras, drones have very well introduced during the last 5 to 7 years, I think, and even spectrometers, which are not even imaging devices at all. All of it could be a legitimate source of information, and each one of them is widely used at different scales and for different properties. Purposes, sorry. Now, this slide, I put it here with a dual purpose. On one hand, it presents a variety of areas where remote sensing is integrated into a process of environmental monitoring in general. Different phenomena, we can monitor them by remotely located cameras and devices. And on another hand, it sets system characteristics that must be considered while choosing a tool to work with to monitor those phenomena. And those features are, of course, sampling frequency. This is an X, or as we call it, temporal resolution, and spatial resolution on X, Y. And for us, it is always a play or game between both things. There is another axis that should be added here. It's a spectral resolution, which could not be which I didn't know how to allocate here because the response in a spectral in a spectral resolution is not linear, and we'll get there in a minute. I really like this slide because this is the way to show how remote sensing is implemented in environmental science or studies. You see this is a triangle with three ages: vegetation, temperature, and reflectance. It is always within this space. We have more vegetation, the temperature, or more biomass actually, the temperature will be lower. I don't know if you see my pointer here on this apex, and other way around. The changes in the third side here in reflectance are actually not that obvious, and the direction of the change, I mean increase or decrease, will depend on the part of the spectrum that being referred to and on the studied object, of course. And for the purpose of monitoring changes in reflectance, different parts of the spectrum must be isolated and analyzed separately, again, in regards to the object that we study. And this is just an example of how the relationship between biomass and or vegetation cover, if you like, and temperature works. We see here on the upper right aerial photography of one of our forest sites, different surface features, clearings or more dense areas here. And this is how it is presented by thermal imagery. You see the clearing here appears more warmer than the denser stand. It's just an example. Okay. Now this is the well, next to slide more or less. I will briefly cover the entire theory that is behind this. The slide with all its sub-regions. We use almost all of them, starting from very obvious visible part, moving to near infrared and far infrared, and then to thermal and microwave parts of the spectrum, longer waves. Almost all of them are in use, and in the middle is the spectral signature of the healthy leaf, invisible to mid or shortwave infrared part of the spectrum, and in this signature divided into three subregions. Each one influences or the influence of an object we measure in each one of them. The pigments are influencing the visible part from blue to green, the internal leaf structure and absorption in
we have some problems.
also.
Michael, we have some little problems, it seems, with the internet. Suddenly we lose you. Okay.
With what?
Suddenly
and now?
Now it's okay again. It takes a few seconds and you are back, but
you lost me.
Get my cover.
Now it's okay, Evelyn, guys.
I think we have the problem.
Okay.
It's okay.
One moment.
All right. So
one moment, please. I think maybe the problem is ours. You can see Michael. Okay.
Yeah. So I move forward.
Yeah. It's okay.
All right.
We are okay.
All right. So I think it's something. Okay. So we'll move further to the thermal part of the spectrum, because within all the variety of possibilities, meanwhile, we are in KKL decided to focus on three particular areas: mapping, inventory and monitoring, and ecosystem functioning, which is actually the forest health. While remote sensing is helping here to collect the data, to track the changes, and to give us a heads up, which is its main and most obvious role. In fact, I think I should have mentioned here the fire detection and scars mapping. We'll talk about it because it is very intensive part of our work, but I just forget to edit here. Sorry for that. Okay, and now let's start with some examples and what we actually do in these three or four particular areas. Well, the most frequently used source of information is still an aerial photography. It is, accurate, reliable, easy obtainable, and well understandable by all. It have served us quite a while, in 50 to 40, maybe to 50 years, and mainly for photogrammetry purposes and mapping, like defined forest stands, building apps, areas, or transportations, and things like that. And here is an example of how we use it to produce a basic forest map that includes all the parcellation of forested area, the same area that we've seen before on a previous slide. How we differentiate it into basic forest units. And this map includes all those features that usually come from photogrammetry. I mean, again, transportation, hydrology, urban areas, and etc. And it also gives an insight into the species composition of each stand, which is, sorry, it's in Hebrew, but which is defined here by color, whether it Pinus salapensis or mixed stand or cypress or whatever. Okay, this is again basic forest map that we use day by day, every day in our managing our plants. From a practical point of view, I think any change to the area is recorded and projected to the map that is updated on a yearly basis. And remote sensing helps here a lot, and ground surveys are not always required to mark the change that occurred. This is not too complicated use of remote sensing, but however, quite an historical one. And as you see this aerial photography of the stand, and this is the map at one point of time, and this is the change that occurred. So we use it to correct the map and to draw a new boundary of the stand and even define the species composition. Again, not too complicated, but very classical use and very comfortable to us to use it. Now, if we want to study species composition, which is very important in every vegetation in every vegetation study or managing the forest, I believe that we do not have any other choice but using spectral signatures obtained by the hyperspectral tools. So very high spectral resolution, many narrow band in visible to shortwave infrared part of the spectrum, and of course very high spatial resolution. Just we should be able to detect every tree or every small group of trees within the imagery. And this is a very complicated step, specifically in Mediterranean environments where stands are naturally very complicated. We do not have such an ability in-house, and this is a good example that of the study that we have funded to have to get the answers. The study was done by the researchers in Ben Gurion University here in the south, and initially it aimed to map only the invasive species. You know, invasive species is always a problem in every forest for every forest service, and we are not we are a good example for it. However, the study very fast widened into a species composition in general. The researchers used an airborne platform and statistical tools for obtaining spectral signature of different species and further on to classify the image. So they have two strips of aerial imagery in the southern part of the country, and they were able at the end to map over 20 species within these two strips. An environment was, believe me, very complicated. Okay, you see the species composition is quite unusual. This is how we use the hyperspectral tools in mapping, again, in mapping and species detection. They even go further for some ecological, let's say, ecological part of the study to study the biodiversity on different spatial scales and evenness of the areas. Now that was about mapping. Now let's move into forest inventory. You see, if you remember, there was a second goal of using remote sensing and any monitoring technology in KKL. It is obvious that we should know exactly what are our resources and how we can use it. And it's also obvious that it in easy, specifically in complicated sense, as I mentioned before, when you operate from above and you see the area like this, okay? So a while ago, we decided to run a pilot project of a very small stand in one of our central forests, or forest in the central part of the country. And for that purpose, we use drones and only RGB part of the spectrum, like a visible part, red, green, blue bands. Today, everyone and we also using drones on daily basis, but then it was quite a new tool in the market. So the drone have take many images of the same point from different angles. It builds the 3D model of the surface, you know, digital surface model, digital terrain model. It detects the tops of each visible tree, marks it, and know how to calculate height of this tree. And so we had a number of trees per area and average height for this area. And for the latter, we have an allometric relationship to diameter of breast height from our ground surveys. And also we have a number of trees per area, which is the stand density measure that we use here in Israel. I'll talk about it a little bit later. And this is an example of the stand, how they mark the trees. These are the measures on the left that were taken from above. And now this is the ground truthing. The ground truthing is less important now, but they're here. We went to the stand, we measured the height, the DBH, we calculated the number of trees per area, and this is the general direction of the relationship between both parameters. An absolute error for 3 TPD is trees per dunam, or it's actually trees per hectare divided by 10. And the error was quite small for all parameters. and the accuracy was good. So we repeated the study in different, more complicated stands. I will not show you. I'm not showing it here, but the results were pretty much the same. And today we are trying to introduce this technique to save actually time for our surveys. We also try to implement spaceborne platforms and sensors such as Iconos or recently Lancet 8, actually, with different classification algorithms to obtain a map and map the same forest measures on larger scale. Satellites, of course, lower the prices of the process and cover a larger territory, which is always important. This is another study that have done by researchers in Ariel University, and it was proven to be valuable because the comparison to the ground truth data, mean absolute dBH difference here, is quite small. 4 centimeters or even 5 centimeters for us or for our type of forestry, which we don't do it for timber, only for greening and landscaping. This is a very accurate result. Another step of the inventory is to obtain information over recently planted stands, calculating the survival rates in order to evaluate the success and decide what to do next with this stand. I just will open the parenthesis. I believe that Gilad discussed it or mentioned it in the first lecture. The forestry in Israel started in mid 20th century by massively reforestating and afforesting the land. This process continues till now, mostly in southern part of the country where I work, and such a type of survey is very important. We do it 5 years after planting. The plantings are we plant forest mostly in some regular way, as you see here. So using drones for at different scales, actually, not only at small scale here, could help us to know whether the trees are survive this 5-year period or they actually dry down and dead. So we're using drones and we use drones in this study in 2 spectral ranges, RGB and near infrared, to be complementary one to another. And we detect each tree within the studied area and classify it whether it's dry or alive or live tree. And here just an example how near infrared, so I mean longer waves, help us to correct the information that was obtained by RGB imagery on the right side. On the right side, you see the RGB and trees classification, dry or live, and this misclassified tree was corrected by the near infrared part of the spectrum, as you see here on the left. Okay, so this is a very good example of how different parts of the spectrum could be complementary or integrated together and implemented together and could be complementary one to another. Again, ground surveys, less important now, but the overall success in classifying the trees was about 90%, which was very good and very promising. And again, this study we also repeated in other stands quite recently, about 3 years ago, and the results were the same. Any questions till now? No. Okay, so let's move to the stand density. Special attention actually should be paid to stand density because this is one of the most critical measures in forestry, particularly in areas that lack resources, like we are here in semi-arid and arid environment, and also because this is, let's say, only silvicultural parameter that actually can be manipulated by forester during the stand development. This is again theoretical side. There are wide variety of measures that can be found in the literature. We in Israel primarily use absolute one, like basal area, and more frequently trees per unit area. However, in my opinion, relative one have their place in such a non-timber forestry as we have here. Stand density cannot be easily obtained from remote sensing imagery, especially spaceborne with lower spatial resolutions, and the imagery should be interpreted right. I will just show you a very old study that we done in the Yatir forest, the largest planted forest in a dryland here in Israel. And we calculated, this is quite a big area, using, it was based on Iconos imagery, 4-meter spatial resolution in visible and near infrared part of the spectrum. And we calculated canopy cover and then relative density measures, and through it we came to trees per hectare. Of course, comparing to ground surveys and etc. The study was published quite a while ago. And again, from the density, we were able to obtain other forest measures like diameter at breast height, canopy area, height. The relationship are quite linear, so the ability to predict a number of trees, as I write here, will lead to ability to assess any other forest biometrics. And again, this is important in saving time and labor of our ground crews, the surveyors, actually. The technique is very tedious. We had not repeated it since yet, and hopefully we will do it, and if you will use it in the future. Now, from inventory, we'll move to ecosystem monitoring and forest health assessment. Actually, this is in my opinion, this is the real power of remote sensing, and its ability to capture the same scene repeatedly, day after day, year after year, or even on daily scale. And this information can be definitely used in monitoring forest health or other phenomena for a long period of time. The oldest project that I can remember has been done for us by researchers from Ben Gurion University, the Institute for Desert Studies in the very south. They actually monitored vegetation dynamics following the drought of the late 90s. It was very serious drought. This is the same Yatir forest on large scale. Lancet imagery was implemented here. They use change detection technique. I mean, the difference between two images from different time points. And they capture biomass change seasonally from wet to dry season, before the drought, during the drought, and after the drought, and calculated the direction of the change. That was an academic project per se, without clear management purposes, but still monitoring is monitoring, and this is just an example of how can we use such techniques in even for forest management and in our everyday work. Another way to monitor change is just extracting pixel value or some average value of a region of interest for a long period of time. Like we did here in upper left is in the change in NDVI and vary over the same pixel in Yatir forest. You see the decline of the values from 2002 till 2014. And the decline continues further on. I just don't present it here. I'm not presenting it here. Or we use the same one on annual scale for forest for fuel moisture content extraction from one of the pixels in the forest in Jerusalem, located in Jerusalem Hills. Again, you see the decline for 20 years. Very interesting and phenomena that should be studied more properly. Okay. Regarding the monitoring, AT and a combination between GIS and remote sensing and ground surveys, about 8 years ago, we started establishing and established already, of course, our long-term monitoring program, which aims to follow vegetation dynamics of the mature pine forests all over the Israel. The program based on 230 mature stands located over the precipitation gradient from north to south. And from this 230, we extracted 80 permanent plots that we put on the ground and decided that will be these will be for field campaigns. Though those campaigns repeated every 5 to 7 years, or should be repeated every 5 to 7 years, we already have 2. And however, the entire population of 230 is monitored constantly for NDVI change and dynamics using Landsat imagery. Okay, these are some results from we analyzed the imagery from 1994 until now for 2 species over these mature sites, Pinus salepensis and Pinus brutia. And here's just a comparison how NDVI changes according to an aspect and precipitation gradient for both species. Again, we did it by just extracting vegetation index value for specific region of interest and building this graph for this plot for the change. Next large-scale program that has not been established yet and still under construction is our forest health monitoring program. We're still formulating it, and as planned, it should be based on thermal infrared imagery, canopy temperature actually, starting with image analysis and occasional ground surveys for detecting the weak areas. And all over through this diagram, the imagery, the ground surveys for ground truth, and reporting and mapping part of the process, and collecting everything is in collecting everything or putting everything in GIS for analysis. The main objective of this program is early stress detection, just before the stress could be visible for other part of the spectrum, because I think, and I'm sure that near infrared is almost a unique tool that can support such an objective. However, using thermal imagery in natural environment like forest is not trivial and not frequent comparing to its wide use in agriculture. We are the very beginning here and have started with two steps. The first one was to calculate a canopy stress index, or water stress index as we call it, for each, let's say, for that purpose, Lancet scene, 30-meter spatial resolution, and follow the index dynamics over certain stand or the entire forest for the period of time. The period of time. The main trick here, actually the main trick in such monitoring, is to define the normal behavior of the pixel on annual scale or interannual scale, and then to look for differences between the normal pixel and the current one that is obtained recently. And by comparing one to another, we can see the change and decide whether this change is positive or negative. It is not an easy task because thermal imagery still have low spatial resolution if we want to use it for on stand or forest scale. However, drones made some progress recently, and I'll show you in a minute how we use it. This is an example of several stands in the forest, and this is the same example of, I mean, it's not the same example, but the example of how we use it in over the entire forest. Again, calculating an image and going scene after scene all over on annual scale from April to October, from April here on the upper left to October here on the lower right, and you can see the change in the canopy temperature. Of course, everything should be just an example and a pilot project, so everything should be studied deeper. And another one for much smaller area. Here we use thermal imagery to follow the transpiration dynamics in a small part over the small part of Yetir forest, again on annual scale from May to November. And by extracting values here on the plot, we can see this seasonal dynamics, how transpiration drops down from June to October, and then June here, October here, and then it increases again with the in very beginning of the wet period in November. Again, I'll show you again. This is the dynamic of transpiration. Now that was the first part. The second step to initiate this program was to initiate the research, of course, and this is what we did with the same objective: to detect forest stress or plant stress just before it could be visible. This research has been done in collaboration with agricultural research organization, Volcani Center, Ministry of Agriculture actually, and we started this experiment by testing the behavior of the saplings, first of all, in controlled environment, in order to answer two questions. First, what is the temperature difference between well-watered and dry trees, again in controlled environment? And the second one, when this difference appears, at what stage of drying of the forest? So we took 24 saplings of Pinus salepensis, 12, we irrigated them all at day 1, and then 12 we left for drying, and another 12 we were irrigating each day until day 18. We took thermal infrared imagery here from close range camera every minute during the daylight for 18 consequent days. And this is some example of how temperature changes from day 1 to day 18. The red are dry saplings, and the blue is the temperature of wet saplings or irrigated saplings. at the very beginning, there is no temperature difference, and you see how the difference increases until day 18. That was promising. That was a promising result. And then we moved to the forest, the second phase of the research, physically damaging the trees, like here, in order to expose them to a beetle attack, to weaken them and to expose them to beetle attack. And beetle, of course, will initiate the stress. Then we obtained drone imagery 3 weeks after the exposure, 5 weeks and 7 weeks after the exposure. The imagery was taken in two spectral ranges, in thermal part and near infrared part of the spectrum. And these are some results. I would say the results were not promising at all. We barely could see some differences between exposed and not exposed trees, or the differences between images taken over 3 to 5 weeks, and etc. And it's all just proven that early stress detection in natural environment is not an easy task. But I believe it could be done. And we will continue elaborate these results and these studies further. Definitely. Another example of how we use aerial photography in visible to near-infrared part of the spectrum to classify trees in the forest. This one taken by aerial photography, and this one, the upper left and the lower right in the Nashe forest at drone platform. The scale here is quite small, and I believe the drones are very well, or forest health monitoring on smaller scale has more promising future than on larger scales. Okay. Now the second last thing that I want to show you is what we do with fire monitoring and mapping. Recently, it became a very intensive and important part of our monitoring and reporting activities. Though we don't have many big fires over the year, but calculating the burn areas, even if they are small ones, and assessing the severity and providing this information to management to build forest restoration plans is very important. We are developing these abilities in-house to be as independent and as fast responding as possible. Just do it on premises. There are two examples here. On the left, the forest areas that were burned during several escalation rounds of the conflict near Gaza Strip. And while the right one is one of the bigger events in Jerusalem area. This is the index that we used. We used several others. The left image was obtained from Venus, and the second one here on the right from Planet Labs imagery, both at very high spatial resolution and very high temporal resolution. So we introduce in some recently developed and available tools for this purpose. We also follow some vegetation recovery after the fire by simply calculating the change in vegetation index. This is another example, quite old already. And even the change is not statistically significant, it is always important to see the direction of the change and that the change is happening at all. And even visual analysis show us that the area that were burned in August regenerating in October, several months after the fire. We can also do it by doing the same by applying more complicated approaches like Markov chain classification with biomass calculation and mapping vegetation recovery throughout the regeneration, marking every tree and species composition, etc. This is a very recent work from the last 2 years done by researchers in remote sensing laboratory of Haifa University. It is very promising, especially in light of recent fire events, and we had just 3 weeks ago two of them. Very large area of the forests were burned. So to know what regenerating, when regenerating, and where regenerating, will be very important to us again to build the plan of forest restoration and allocating resources. Basically, we prepare ourselves for fire season by calculating two major parameters: fuel moisture content on the left imagery, based on long-term vegetation dynamics and the Australian model, and the fire danger index that is based on topography, fuel moisture content as an input, and vegetation composition. I believe that you remember one of the first slides with basic forest map and forest parcellation with all these results from ground surveys and remote sensing assessment. These are both very useful and important tools because they allow us to be ready to the season and to navigate through the event once one happens. If we know the danger, or when we know the danger, and we know where the danger is higher, we know how to use that knowledge to move our forces to fight the fire. And this is an example of how GIS could be integrated, or integrates actually, the data from remote sensing and other sources. And we calculate time of arrival of our forces. These are small trucks here on the map, to almost every stand in the forest according to trafficking and previous calculations of the danger. To summarize the fire part, we have a forest fire reporting system that collects all the fire database from 2016 already. Every fire is detected, mapped, managed, and inserted into this and stored actually in this system. Everything here is in Hebrew, but this is actually available for general public. Some statistics, and we will have plans to translate it into English to be more suitable to the world. Okay. This is how these were examples of how we integrate the data from different sources into GIS, analyzes it, and present it to the managers. Okay. This may be the last thing or second last thing again that I would like to show you. Very old stuff, the countrywide leaf area index mapping. We know that leaf area index is one of the basic and most important vegetation characteristics. It is informative and gives a lot of information about forest maturation, recovery, functioning, and health. It can be used to manage the land by monitoring physiological activity of the forest and its status. We do not really measure it constantly, but it was used once to monitor countrywide seasonal dynamic of this parameter. Maybe we'll get back into it someday. Now, these are two slides I'll skip, the less important. And we cannot, actually, I cannot finish this presentation without mentioning ArcGIS Online and all those goods and services that it provides by creating and analyzing spatial data and sharing it over different platforms. It had, by means of it, we can actually reach almost everyone in the service and help him or her to build the day. We can plan the activities at different time and spatial scales to share the data with the different users and to help managers to have more spatially skilled decision making. It is the next generation of ArcGIS and is in very intensive use in KKL, and this is a basis on which we build our forest management system that combines all that we have discussed here today: mapping, inventory, ecosystem monitoring, fire detection, and it is actually a real-time monitoring system that saves time and many other resources at different levels of measurement. This is a front page, again in Hebrew, but it doesn't matter, and all those around are parts of this system, starting with annual plan for the region or inventory over the entire country, and of course fuel moisture content as a preparation to fire season. And we are just beginning for this year. Let's see what we have until October, November. It is widely used. I start my day with it personally, and I end my day with it every day. Okay. Now, Evelyn, I don't have any formal summary for this talk, because what else could I say? I think we need up-to-date information in several directions from different sources at different scales to grow healthy forest. And I would argue that this is no doubt that would be our major objective as a Forest Service. And I think it's pretty much all that I prepared here today, around an hour. Okay.
Okay. Okay.
Back to you, Evelyn.
Thank you. Thank you very much, Michael. Thank you. Thank you. Very interesting.
Okay.
Yeah, we don't have, we have one question actually, but maybe we have a possibility to hear from our friends here. Maybe if somebody has an interesting experience in using this type of technology, or someone would like to share with us? No?
Which question do we have? What question do we have?
We have one question about organizing. There is one question more. Okay. Well, we have a question from Devis, from a French speaking country, don't know from where exactly. He is asking if there is any possibility to organize a training for 1 month, or about the use of drones in order to collect data, or in general about this subject. Do you think we could think about organizing a training?
I think we will be pleased to do so. However, I'm not the right person to answer that question.
No,
Okay, we
on
have
the
it
on
is a good idea. It is a good idea, a nice idea, and we can do this because we use it quite a lot, and specifically for fire monitoring and monitoring purposes. Recently, during the last, I would say, 2 to 3 years, we have a special unit with such an abilities, and I think it could be done. on organizational level. I'm not sure about the 1 month or whatever, but the time scale should be discussed further. But yes, I think we'll be glad to do this. And I
Well,
see there is another question
yeah,
from.
maybe let me only
Okay,
add
sorry.
some information about trainings. In general, we as Mashaf and the Ministry of Foreign Affairs, for many years, we are collaborating or cooperating with KKL for different activities, training activities, international programs normally. We did it quite a number of times, and maybe the result of this series of webinars could be a face-to-face training here in Israel, hopefully, okay? Those types of training programs normally are promoted by our embassies. So we come out with a brochure with the subjects, and we promote it by the embassies, and professional people are invited to send an application. There is a selection, etc. So thank you. Maybe we will be able to do it. Okay. Yeah. Do you see the
There are
question, Michael?
yeah, there's a question from Mixon. When you do the restoration program, do you consider fuel soil moisture content or other characteristics? No, actually we don't. We we use only other characteristics like the site, the climate, and we definitely try to use as many local species as possible. Fuel moisture content is not considered here. No, it's restoration is quite a simple. It's quite a obvious silvicultural practice, and there are other parameters that are in use. That is, several people are asking whether I can share my presentation. Of course, I'll send everything to Evelyn, and Evelyn will do it probably in some way, right?
Yeah, we are sharing. You will be able to see all the presentations again in the videos. Okay, maybe presentations are quite heavy, but I will put in the chat again the link to the playlist where all the recordings are uploaded. Okay.
There are other questions, Evelyn. From
Yes.
Ararat, what are the software programs you use more often to analyze the data? We used once an ERDAS Imagen, and today we're frequently using ArcGIS, with different modules, because it is quite a powerful tool even for image processing. So no specific image processing software we have here. The universities probably definitely have any other available software. Okay. Now, for countries having official buzzer notation, implement remote sensation and further reports. The question from Marvin, for countries having official, you don't see the question. Well, you do see question. Official budget limitations to implement remote sensing and GIS infrastructure to forest land monitoring. What are other alternatives that can be capacity to mobilize local communities and record changes in there? Well, it's a good question, and they actually don't know how to answer that. I would recommend starting with what you have on small scale, and gradually increasing it by convincing the managers or the management level to put more budget in it. Because once you prove that this is a reliable and accurate tool that can save resources, actually, they will be convinced, especially putting, many other colorful imagery and presentations. They will be definitely convinced to put more resources. Okay, I don't know how we do not work with local communities here for forest monitoring. However, we have a good relationship with them, and they inform us on fires and garbage in the forest and damages that they see, but no in remote sensing or GIS aspect. So again, the only thing that could be done here, in my opinion, is just easy convincing the managers. Okay, I hope it answers the question. I don't know. What kind of model of drone are more useful to get NDVI and RGB information? This is a simple DJI platform and Mica cameras. They have different variations of this. So one goes one only RGB, another one four bands with near infrared. There are many that use further parts of the spectrum, like red age, going a little bit deeper into near infrared, and of course the thermal infrared cameras. I just can't recall them now, but maybe I'll put it in a presentation. I will find the information. I cannot recall it right now. No, we don't use LiDAR. This is the question about the LiDAR. No, we used it once for some small pilot project, and from my experience, the correctly taken RGB imagery from drone from different angles, and it has an ability to build 3D model, and I don't see any advantages of LiDAR technology for that purpose. Okay, so we're not using it, and it is also because it is still quite expensive. Quite expensive. There are companies that can provide this information on different scales, from drones, in Israel, I mean, from drones, from airborne platforms. But it is, again, it costs a lot of money, and we still preparing to keep the money for other things.
I
Okay,
can answer the question about the
water and irrigation. About
no.
what?
No, it's okay.
There is
No,
another question. How do you conduct water and irrigation management of trees
Yes.
to ensure survival? We have after we plant the trees, for first 3 to 4 years, actually, we just irrigating them constantly, or by drip irrigation if it's a small stand that we would like to assure to assure the maximum survival and fast development, or we just irrigate it from the trucks, big water trucks, 4 times during the first year after planting, 3 times during the second one, and 2 times during the third one. If those years were quite dry and the precipitation level was low, we add additional year, or maybe additional, let's say 5, not 4, 3, 2, maybe 5, 4, 3, and then another one for the 5th year, just to support the survival. That's the way.
In session two, you can find maybe more information about the implanting of new forests. Okay. I understand there is difficulty to go to the playlist. I am sharing here also our YouTube page. Maybe it's easier. Okay, so please copy. You can get to the videos also through the YouTube page. There are some more questions.
No, I don't
Michael,
see
it's
one.
true, yeah, from Marvin.
It's true that
The
backups of
back,
electronic data can only last for 10 years or so, and the quality of data degrades over time. It is still preferred to drawn physical copy for documentation. You mean the physical, the hard, the map, the physical map? Is that what you mean, Marvin? Yes, we still use maps, of course, because, you know, as I mentioned, GIS and all this mobile technology, everyone uses WhatsApp. But when you add some a little bit more complicated application, it is hard to convince several people to use it. But so we still plot print maps and use maps, but the use of them is gradually decreasing. Actually, more and more we use iPads and the mobile phones to provide the information. The location accuracy increases, so that's the way we use it. Do you encounter pest disease in the forest? How do you manage them? We have annual surveys, ground surveys, for pests, mostly uh, in the very beginning of the autumn, starting November or late autumn, actually, November, December. And then we have practice to spray biochemicals to ensure that the forest will survive the attack. This is what we do. And as I mentioned during my talk, I would be very happy to see forest health monitoring program established and working, but we're still developing it. Again, forest is a complicated environment, very hard, and it also very hard to convince people to use it and to actually to put a budget. That's the key issue, the money, always the money. And another question from Ararat, can I calculate carbon fix into the soil biomass or vegetation index in an indirect way using an index or math calculation? Yeah, there are some studies. You can find it in. We don't do it, but you can find it in the literature. There are some studies that use remote sensing specifically for that purpose. Again, we don't do it because it's more research scientific objective. Okay, for everyday forest management, we less do such calculations and carbon sequestration assessment. But this is also a point that should be discussed. Okay, I hope I'm answering all those questions, guys. You just tell me. How do you integrate fragmented forest and management model? Different colleagues have stakes on a large tract of land with varying degrees of interest. I'm not sure that I can answer that. Let's try. Have stakes. This question is more for timber forestry. We don't have such things. We don't have organizations or stakeholders. Actually, we are the stakeholder and the country is the stakeholder of the forest. So any fragmented forest land management is or monitoring is we define the purpose and we define the way how we do it. No other authority could be implemented here in the forest. So no stakeholders. Uh, Invasive species, of course. Do you use this technique to monitor invasive species? Of course, and I started my presentation actually with species composition mapping. That was initiated. The research was initiated to map and monitor the invasive species, and we repeated it recently in other environment. Yes, we do it. Who don't have high technology for monitoring. Well, Marvin, let's. I don't know how much time do we have to discuss such things, Evelyn, but we can proceed further in personal discussion, Marvin. You can write me an email or call me, and we will continue this. Okay? I think
Right.
that the question is quite specific.
It's a good idea, Michael, if you can share your mail in the
Of
chat.
course. I'll put it here right now.
In the meantime, I can answer. There is somebody
This is
who,
me. This
who
is me. You
said
can write me
about
anytime. Vegetation, temperature, and static stuff. Mobile application for wildlife, mammals. No, we don't have Rarat. We don't have applications for such remote sensing applications for, or not that I am aware, for wildlife monitoring and detection. I know that the other authority, Maharag, I think, Evelyn, they use phenocams that they put in the forest and different on trees to monitor wildlife, but we don't do it actually.
yeah, there are other organizations that are dealing with birds and animals in general, or maybe yeah, others are doing
Okay.
it better. We have another question in French, and I will try to translate it. Okay.
Okay.
In the meantime.
Okay, this is not the language that I.
Yeah, thanks God we have Google and other.
Google Translate.
Or
Okay.
here, yeah. In my country, we cut down a lot of trees to produce coal to cook food. Do you have any other way of cooking food without cutting down trees?
Just using gas. I don't know which country are you coming from and what are the resources that you have, but I'm not the author. I'm not authorized to answer this question because I have no idea. I use gas in my house.
Or electrical
Or electric
gas to
heating.
cook.
Yeah. I'm
Where are
sorry.
you from, Devis? I don't know how you call yourself, Devis. Let us know where are you from. Somebody wrote down the idea of opening a WhatsApp group. It's a great idea, but we are a lot of people here, so it would be quite difficult. Okay, but maybe you open a group in a Facebook and invite friends. Maybe once. Okay. Burundi.
Okay, I don't know actually how to refer to
In
this
Africa,
question. I'm sorry.
yeah. I can tell you we have a nice technology for cooking without cutting down trees, and it's called using biogas. So there are some systems you can have a look in the internet. Company is named Home Biogas. I will put it in the chat. Have a look at it. Interesting. It's using all what you are throwing from the kitchen and even dung from the cows, etc. And it's producing gas for the family for cooking. Great technology. Yeah, here Edward is also telling you about biogas.
And Bharat has an answer also in the chat.
Yeah.
Okay.
Yeah, some other ideas. This is a nice question.
Yes, we do, Marvin. Yes, we do. As much as possible. Again, Edward, we do not, and Ireland is also natural landscape. There are. We are not a forest in all the desert, but only certain part of it, and we have regulations and the country and the government to regulate us. We are not going everywhere. We keep the pretty good mosaic here in the south. But of course, we would like to see green, and forest is always nice, and we try to as much land as we can. Yes, the government must regulate, and it is regulating, of course.
Okay. Dear friends, I have just put also my email. Some of you for sure received an email reminding you about these meetings. Here you have the email again. So maybe if there are more questions that we are not able to answer now, or maybe other questions about other subjects that it's not Michael's subjects, please send to us. I will share it with Shani from KKL, and we will try somehow to answer other questions. Maybe if there are lots of questions, we can think about like a roundtable after we finish this series of webinars. So maybe some of you can share your experience. We could think about different ideas. So if you have any idea, please feel free to share it with us, okay? And maybe we can come out with a new program or something like that.
Thank you very much for having me, Evelyn.
Maybe for 1 second, friends, let's open the cameras and let's say thank you to Michael. Yeah, he should know a bit to whom he is speaking. Thank you.
That's the point of Zoom. You speak to yourself mostly.
Thank you. Well, so maybe we can even do a picture together. I will take a picture. So, friends, thank you very much. Michael, thank you so much.
Thank you, Evelyn.
Thank you for having me. Thank you, guys.
Thank you to all of you joining today. Next week, it's our last meeting. It's the 5th session of this series of webinars. So next Tuesday, 20th of May, 3:30 3:30 Israeli time. See you next week, I hope. Okay.
Hello.
And
Hello.
yeah, and shalom from Israel.
Yeah.
Yes.